Okay, so let's take a look at another alternating series. We're going to take a look at the alternating harmonic series. That's a very common example. Okay, so the alternating harmonic series is 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, and so on and so forth. We're going to write it in a nice summation form as the sum. N goes from 1 to infinity. I'm going to write this as -1 to the n minus 1, 1 over n. Okay? So here, our b sub n is 1 over n. It is decreasing. And the limit as n goes to infinity of b sub n equals 0. Okay? So the alternating series actually does converge. Okay, this means this is what's called conditionally convergent. Okay, that means that the alternating series that goes with the series, or before I do that, I should define what absolute convergence is. Okay, so the series AN is absolutely convergent. That's actually the term that our book uses. It's not the same as conditionally convergent, okay, but absolutely convergent if the sum of the absolute value of AN converges. Okay. Now, a series that is absolutely convergent has to be convergent. A series that is convergent but not absolutely convergent, like this one here, is called conditionally convergent. I'm not sure if the book uses that term, but it is the proper term. Okay, that is the term. Okay, so that way we have a language to use. We don't have to say convergent but not absolutely convergent. Okay, so another example, let's do another one. Let's look at the sum. N goes from 2 to infinity, -1 to the n over n log n, natural log n. Okay, so now our b sub n is 1 over n natural log of n. Okay, it's pretty clear that n plus 1 times the natural log of n plus 1 is bigger than n natural log of n, right? N plus 1 is bigger than n. Natural log of n plus 1 is bigger than natural log of n for positive numbers for sure, okay? And that's what we're dealing with anyways, okay? So b sub n plus 1 is less than b sub n. Second, limit as n goes to infinity of b sub n equals 0. So our alternating series converges. What about, is it absolutely convergent? Now, you know by the context of the question that it's not, but why not? Let's consider the sum 2 to infinity 1 over n log n. Okay, well, we actually have the integral test. Y'all remember the integral test? That's right, integral test. So let's consider the integral from 2 to infinity 1 over x log x dx. Now, it's tempting to think, you know what? It looks like, I don't know without doing the integral, okay? I mean, I do because I did it earlier today, but otherwise I actually had to do it. So let's let u equal natural log of x, du equals dx over x. So this is going to become the integral natural log of 2 to infinity of 1 over u du. Actually, yeah, because I'm doing it from 2. Okay, so, but that's still going to be infinite, right? Because that's going to be, I mean, this is an infinite integral. You figure it out, right? But we know that. That's going to be infinite. So this is divergent. So the series in question is conditionally convergent. Convergent, but not absolutely convergent. Okay. All right. I think I just have, oh no, I have a couple more things to do. See you in the next video.